Hello everyone and welcome. In this video, I will introduce you to one of the main goals of Work Package 2 of the SC4 EU project, the development of the True Demand Knowledge Graph. We will explore this knowledge graph idea, discussing how it works, its potential benefits, and the opportunities it opens up. Let's dive into the details and discover it. The True Demand Knowledge Graph is a semantic model based in digital reference. It has three main functions. As one of the main components of the True Demand framework, it stores survey data in the form of a graph database. This allows for capturing the relationships between different data entries, making it easier to integrate various types of surveys. For instance, surveys conducted by OEMs, Tier 1 and Tier 2 suppliers can be seamlessly integrated, offering a comprehensive view of the market landscape. Secondly, by providing a model capable of translating between technology nodes and market segments, the True Demand Knowledge Graph helps to break down survey results into more granular data. This finer detail enables more precise analysis and deeper insights into specific market segments and technological trends. Last but not least, it facilitates the integration of survey results with external data sources, enhancing the relevance and comprehensiveness of the information. For example, it can merge survey data with trade data or other external datasets, providing a richer, more informative picture of market dynamics. Now that we know what the True Demand Knowledge Graph is, let's go step by step through its creation. The process begins with a comprehensive survey designed to gather detailed information to understand the market demand. Each filler will enter current and future demand data in percentages. It is important to mention that the survey is completely anonymous to protect participants' data privacy. This would be an example of one of the surveys, where the current and the future demand of the different technology nodes is obtained. Once collected, the data needs to be mapped to the knowledge graph, but first, it is important to develop a model, as this one. For the current example, the data will be fit in this demand area. For instance, here are defined the results obtained in the second question, defining the relations and adding the value for each of the quarters. Using Neo4j, we can visualize the knowledge graph and see how the survey data integrates into their respective classes. Let's execute a simple query and see more in detail the values mapped to the knowledge graph. We can, for example, learn what is the change value for each demand that is registered. Then, as you can see, it is shown in a simpler graph. Now, let's delve into a practical example to understand how the True Demand Knowledge Graph would work. As mentioned before, one of the main characteristics of the knowledge graph is to be able to make relations between the technology nodes to market segments. For instance, let's consider the technology node 28 nanometers to less than 65 nanometers, which is commonly used in the automotive industry. This market segment can then be further expanded into more specific categories using the Harmonized System, HS. The HS is an internationally standardized system of names and numbers to classify traded products. For example, within the automotive segment, we can have categories such as electric vehicles, buses, and trucks, each of them with their respective HS code. This would provide more detailed information of the demand for each technology node. From this point, the True Demand Knowledge Graph can seamlessly connect to external datasets, such as Barkey. The Barkey dataset is a comprehensive international trade database that provides detailed trade data which can be integrated with our knowledge graph. By integrating this data, we can extend our knowledge with more valuable insights, enhancing the accuracy and depth of our analysis. To illustrate this, let's consider a demo question. What is the trade balance for EU countries with respect to the automotive market segment on 2021? First, let's identify all HS categories that link to the automotive market segment. These categories will include all types of vehicles in the automotive sector, such as trucks, public transport, or conventional cars. After that, as for this example we will consider only the EU countries, we will compile the countries belonging in 2021. Now, we will collect the data with a SPARQL query. We will obtain the total amount imported and exported by each country in the products related to the automotive market segment in 2021. With these quantities, We proceed to calculate the trade balance by subtracting total exports from total imports. In this way, we will obtain the balance of each country, as you can see in the graph represented by the orange bar. Through this example, we can learn how the true demand knowledge graph, combined with external datasets, will offer powerful tools for a more detailed analysis into market trends. To conclude with this video, it is important to highlight that the idea shown today is just the beginning. More will be showcased after year 2 of the project. The true demand knowledge graph idea will continue evolving and more advanced details will be demonstrated in the second year of the project. Thank you for watching, and stay tuned for more updates.